The speed of light is over 299 million meters per second, or over 299,000 kilometers per second. Speed of light is as well the fastest achievable speed in the universe, or not really achievable. In order to go at the speed of light, you would have to have no mass or no materials that you are made of. Meaning, in order to go at the speed of light, you can't exist physically. But we can get very close to the speed of light. Light speed may seem like much, but taking into consideration interstellar distances, it is not that impressive and does not match our human ambitions to reach other stars fast. Sure, light can, in 1 second, go around the Earth 7.5 times, but since light has its limits, even when you're talking to a human 1 meter away, you would see him 3.3 nanoseconds in the past, or almost a billionth of a second in the past. Everything you see around you is how it was, not how it is now. You can never see anything in the universe as it is now, but only in the past. So let's start with familiar objects such as our own moon. It is 380,000 kilometers away on average, meaning from Earth we see it 1.3 seconds in the past. Our Sun, as we see it, is 8 minutes in the past from Earth. And Mars is 14 minutes on average in the past, which also means that rovers, humans sent there, need an average 14 minutes to respond to a single command from Earth. And also means that you can never see Mars live, as well as anything, since light speed is the limit for every speed, including radio waves, microwaves, gamma rays, and every other wave. Now let's go a little further. Another star, another system. The closest star system is Alpha Centauri. It is 4.3 light years away. It has 3 stars, and the smallest star, Proxima Centauri, is a little closer, 4.2 light years away from our Sun, meaning that it takes even light 4 years to get to Proxima Centauri. Now, there is an Earth-sized planet that orbits Proxima Centauri, and it is likely solid. So let's suppose there is an alien observer there now, and if they had a big enough telescope, the mirror likely has to be a few thousand kilometers in diameter to observe Earth perfectly, and the alien observer would see Earth 4 years in the past, which from space the Earth would look pretty much the same. But if it was an extremely large telescope, let's say 25 million kilometers in diameter, and it could pinpoint every human, it could see you 4 years in the past, because light from an alien observer is just reaching them from 4 years ago. This also means that when we observe Alpha Centauri stars, we see them 4 years in the past. The same goes when observing every other star. And Milky Way galaxy as a whole, the center of our galaxy, is 25,000 light years away, meaning we see it 25,000 years in the past. So then let's go a bit further with stars. Let's say a star 2,000 light years away that has a solid planet. There, an alien observer would have to have a telescope likely over hundreds of thousands of kilometers in diameter just to observe the Earth from a planet 2,000 light years away. They would now see the Earth during the night, not with bright dots that we have today with cities, since there were no artificial lights. But if they could pinpoint every human, well, first they would need to have a telescope that is over 11 billion kilometers across, which is comparable to the size of our solar system. With this gigantic telescope, alien observer that far away would be able to see Romans and other ancient civilizations, maybe as well spot a glimpse of a war that was going on 2,000 years ago. Now let's go even further, another galaxy. The closest big galaxy to ours is Andromeda, which is bigger than Milky Way and in future will collide with our galaxy. Andromeda is 2,500,000 light years away, meaning we see it 2.5 million years in the past. So if an alien observer from Andromeda wanted to observe Earth and its creatures of its time, the size of the telescope would need to be, well, 15 trillion kilometers in diameter, or 1/4 the distance from Sun to Alpha Centauri. 15 trillion kilometers is more than a light year big. It is 1.6 light years in length, meaning light from one side of the telescope to the other side of the telescope would take 1.6 years. How such a telescope would operate is not very clear, but it sure would see Earth 2.5 million years in the past. The thing is that Earth still wouldn't be very different, but there would be no modern humans at all. From this point in time on Earth, observers in Andromeda would see Australopithecus, or all descendants of humans, with their stone tools, and see their way of life, but it sure wouldn't look like an advanced civilization. It is also worth to mention that these observers would see how the Milky Way actually looks like from a distance. Since we are in the Milky Way, we just barely have any idea of how our galaxy looks like. But let's push even more into the space. Let's go to the largest spiral galaxy found, NGC 6872. It is 500,000 light years across, or about 5 times the length of the Milky Way. The galaxy is 212 million light years away. So, again, suppose an alien observer points the telescope that can see even animals of Earth. So the size of this telescope would need to be over 1 quadrillion kilometers across, or 132 light years across, meaning from one side of the mirror to the other side, it takes light 132 years to travel. To get a perspective, a very big star cluster such as Messier 68 is 100 light years across, which is smaller than this supposed alien telescope. So it sees Earth, and it doesn't see today's continents, but rather one continent, Pangaea, since that was 200 million years ago. But they as well could see a blue ball, and they would think that it's an oceanic planet. But while looking at Pangaea, alien observers would get to see the first dinosaurs and many other organisms that are not here today, including ancient deserts and mountains. Who knows what would they discover about the Earth that we humans don't know. So we can continue going back in time even further, but there's no point as of right now, because the further the alien observer is from Earth, the further into the past will it see Earth. Now, to get a perspective of how big these light-year distances are, we're taking a look at Voyager 1 spacecraft, which is not headed for Proxima Centauri, which is the closest star, but if it were, it would take 40,000 years to reach it. Also, Voyager 1 is traveling at a speed of 17 kilometers per second, or 60,000 kilometers per hour, which is over 45 times faster than a shot bullet. So yeah, cosmic distances are a lot larger than they may seem, but we should always work towards improving the speed of our spacecrafts so we can explore this universe and understand it a bit better.